Good morning. Welcome everyone to our virtual field trip. We are live. This is my first virtual field trip, as it is for many of you, so welcome. Today we have our students, we have our teachers, and we have a special guest. Our field trip today focuses on global warming, and I do want to introduce our main speaker. Students and teachers, please welcome Brandon Rodriguez from JPL NASA. This is my first virtual field trip, as it is for many of you, so welcome. Today we have our students, we have our teachers, and we have a special guest. Our field trip today focuses on global warming, and I do want to introduce our main speaker. Students and teachers, please welcome Brandon Rodriguez.
Hey guys, how's it going? My name is Brandon Rodriguez. I'm over at the Jet Propulsion Lab in Pasadena, California. Really excited to talk to you guys today about a very, very important topic, which is, of course, climate change and how that pertains to earth science and some of the work I've been able to do in oceanography. A little bit of background about me. I've been at JPL now for about almost 5 years, I believe. I was a research scientist before that. I worked in chemistry, and I'm also a teacher. So I teach part-time in the mornings, because if there's anything easier than having one job in education is two jobs in education. So I teach at a local high school. I teach chemistry and physics. So I'm very, very passionate about science. I'm very, very passionate about bringing it to you guys. And I'm really happy to be here today to help out. I see you guys have sent a lot of awesome questions. We're going to try to take some regular breaks and address some of those, some really, really smart ideas for us to talk about. But I thought I'd kind of show you a little bit about what we're doing at NASA to give you a feel for how we're going to talk about climate change. So first and foremost, when you think about life at NASA and the work we do, you guys probably think about stuff like this. So you think about cool rovers like the one that's going to Mars in July, and designing these crazy spacecraft that go hundreds of millions of miles through space and drive on the surface of Mars or future worlds. In fact, I have one such wheel here for you guys. So this is one of those wheels that's going to be on the Perseverance rover launching later this month. So really, really enormous, about the size of an SUV. And we're going to strap that to the top of a rocket and send that off to Mars to do crazy science. Now, and again, like we think about NASA this way. We think about these beautiful images from planets like Jupiter. There's a mission there now called Juno, which is taking these incredibly amazing pictures of areas of Jupiter that we've never seen before. Even when I was in school, when we thought of the planet Jupiter, we knew it was huge. We knew it had this great red spot, this giant storm. But now when you look at these images, like how beautiful they are to be able to see in such great detail. This is actually one of Jupiter's moons crossing across the planet, and you can see the shadow on the right of the screen. So it's like a little eclipse, right, if you will. But missions like Juno are now able not only to go around the equator of Jupiter, but also around the poles going this way. And you get images like these ones here. And who would have thought? Who would have thought that, Jupiter, we think of just these brown stripes and the big red eye, would actually have these beautiful blue kind of oil painting like storms on both the North and South Pole. In fact, we look not just in the visible spectrum, but also in what's called the infrared. And you can see things that the human eye can't see, right? Things outside of our kind of limited detection. And you can actually see some of the storms taking place underneath the clouds on Jupiter as well. Really, really beautiful images. So images like this, I think, are what really excite us about space. We think about, again, this idea of NASA does work away, right? It's something you go to. But the truth is that half of the work NASA does is actually looking down, is how we study our own planet. So I've been very, very fortunate in my career to be able to actually visit some of the most amazing places to study our planet, including Antarctica. So this is a trip I took to Antarctica, I think in 2014. And you can see in the back, this is the ship that you take to get there. There's obviously nowhere to land, so you kind of take a little mini boat to get to the actual land that is there. And as you can see, it's full of adorable little penguins. These little penguinos are just camped out, and they've never seen people before. So they're so excited to like, they're not scared of you. They run up to you. And if you see here, you can see their little baby butts sticking out from their little nest there. It was just adorable. Like really one of the coolest trips. So again, the idea is that when we think about our planet, when we think about all the work that it takes to understand what's going on here, NASA is a huge part of that. And one of the ways we do that is through us, really working with you guys, sharing information with you, because you guys are the future. You're going to pick up this work. You're going to be responsible for this planet and making sure that it's safeguarded. So the first place I would recommend for you guys and for your teachers to explore is this website here, which is climate.nasa.gov. And this will show you a little bit about the research that NASA is doing. So if you see that little bar on the bottom, it kind of shows you what I call like Earth's pulse. So like when you're sick, you put a thermometer in your mouth. This is kind of how we're, measuring the health of our planet. And as I saw from some of your questions, the way we do this is by tracking different things like temperature, right, with a thermometer. Or we look at how much ice is melting and how fast. We look at greenhouse gases like carbon dioxide. And if you click on some of these links, you'll be able to see how things change over time. And I'll show you guys a little bit about that today. Tons and tons of information, videos. You can watch just little, animations about how ice rates are changing and how things are looking at north and south poles. We have this data for all over the planet. So this is a really, really rich website for you guys to play with, hopefully in the upcoming school year that you and your teachers will play with together so that you can get an idea for what it is that we're doing. What does the planet's overall health really look like? And how does data show that, right? Before we know what to do, we need to know what's been happening. And this data will really help you guys get a nice firm footing. So as promised, every few minutes, I'm going to stop and just kind of tackle a few questions for you guys. So maybe we can just start with, 3 or 4 questions right off the bat that you guys have about general climate and the work that NASA is doing. So maybe we can just start with, 3 or 4 questions right off the bat that you guys have about general climate and the work that NASA is doing.
Yeah, so Brandon, we do have a question from one of our students, Rafael from Middleton Street School. His question is, what types of greenhouse gases are toxic?
Yeah, that's a great question. So the wild thing about greenhouse gases is that it's not necessarily that they're so bad, right? It's not that they're poisonous by themselves or that we really have to be worried about them in small amounts. It's that we have to worry more about how they build up, right? So a little bit of carbon dioxide is not a problem. Heck, if you're a plant, you'll be happy for it. Great question. So that's how you are going to be able to photosynthesize to make more oxygen. But it's when these greenhouse gases get in such high concentrations that they hold heat, right? And that's where that greenhouse term comes from. If you think about, if you're a farmer, you have your glass house and it holds all that heat in, all that CO2 stays inside. If the heat can't get released, then the planet gets warmer, right? So we want our greenhouse gas levels to be low enough that the rate of heat leaving is, the same or lower than the amount of heat that's being introduced. And the bad news is that we're way past that, way past that. So that's why we're seeing such big increases in temperature on a global scale.
Brandon, one more question. We have another question from a student from Nimitz Middle School, from Leslie Wedam. How is climate change affecting the planet right now?
Yeah, I mean, this is the greatest question, really, because I think one of the reasons we don't see a lot of action on climate change is because sometimes people are a little too short-sighted about a consequence. So people say, what's the problem right now? What's happening today? Well, maybe nothing, but what about tomorrow? What about a year from now? What about 10 years from now? If we wait too long, then how can you react, effectively? So the idea is we want to be proactive. We want to take care of this before it's too late. Now, if you are just a person in LA walking around, you might not notice climate change, right? Your day to day, you might say, oh, it's a little warmer, but that's not what we're talking about. If you are, however, a farmer, or if you're from an island community, you're an indigenous person from up north, or from any of the Pacific islands, you are feeling climate change already, right? You've seen sea level rise overtake beach communities. You've seen ice melt, and the animal migration patterns have changed, things like that. So there are very, very real repercussions already. And just because you don't see them every day, living in a big city, living in a Western society, that doesn't mean they're not there. So we really need to be proactive. We really need to get to work, because those consequences are there, even though we just don't see them.
Okay, thank you, Brandon.
Sure. So really great questions. Maybe we can kind of actually build off them just a little bit. So one of the things I wanted to show you guys was how it is that we differentiate between things like climate and weather, right? So weather is something that's happening today. That's something that we think about as we go for a walk or something like that. Is it cloudy or sunny? Is it hot or cold? So I remember before I moved to California, I lived in Houston, Texas, and there the problem was rain. We would have these hurricanes, and as you can see, this is a picture of kind of before and after Hurricane Harvey. So this is the same highway buried under 20 feet of water, just completely flooded the entire city. So you can see how for different geographies there are different kind of concerns when it comes to weather, that day-to-day kind of event. Meanwhile, if you look at California, when I moved out here, I was shocked because all of a sudden I was never going to see water again. It was so dry, and all of my grass is dead, and I wasn't really prepared for this. I remember driving on the highway with a colleague of mine and seeing a small fire on the mountain and thinking like, oh my God, what are they going to do? And he said, it's wildfire season. You're going to see dozens of these. I was shocked. The bottom left-hand picture is actually from the hill near my house a couple years ago when the fires were coming down the mountains over by the 210. So that was pretty scary stuff. So again, to the earlier questions, are there consequences to climate change already? Absolutely. Now, again, you might just think of, oh, it's a wildfire. What a bad day. But if you're a farmer, you've been feeling climate change for a long time in California, right? Because we know that drought has been such a serious issue. So one of the things that we see is what's called ground subsidence. This is how the ground is actually lowering as we pull water out. Think of it kind of like the sponge in your kitchen, right? When your sponge is wet and you're cleaning dishes, hopefully you're helping in cleaning dishes. The sponge is large, but as it dries, it kind of like shrivels and gets hard and crusty, right? And we actually see that with the earth as well. As we pump that water out for farming, all of a sudden the earth gets more and more dense and compact and brittle. You can actually see that happening in the San Joaquin Valley is a huge example. So what this guy is showing here is this is the ground level. This is where the earth started. Oops, apologies. This is where the earth started right here in 1925. And this is how much the earth has sunk down to 1977. So the earth is literally just getting compact, shrinking, shrinking, shrinking as we pull water out. And without new water to go back in to fill the sponge, the earth is just getting worse and worse in that sense. You can't farm in this soil, right? It's too hard, it's damaged, there's no water in it anymore. So, again, there are real consequences for climate change already. One of the things that we monitor is sea level rise. And this is just a video that I took from the website I mentioned earlier. And what you're looking at here is how the sea level has gone up or down over time. So red means sea level is going up, purple means sea level is going down. And what you can see in the bottom, if you're a bright young student, is there's little ups and downs. Every year, there's little ups and downs, right? And that corresponds to seasons, right? So that, summer versus winter, there's kind of a wet season versus a dry season. But overall, you can see year over year, even though there are little ups and downs, the general trend is very much upward, right? So just looking at, this is 10 years. Over the course of 10 years, you can see already a sizable increase, a trajectory going upward and upward. And as you can see here, as the video ends, by the end of this, just in 10 years, things start to get very, very orange and red, if you will, right? So really quite a bit of observed sea level rise. Now, again, think about if you live on the coast, if you rely on fishing or animals that rely on ice, things like this, this is a problem. This is a real impact. So let me pause again before I tell you guys a kind of a crazy story of some of my research. Maybe we can take another 2 great questions from the audience.
Yeah, so we have a question, Brandon. I think that's aligned to what you're showing them here. Is one student from Griffith Steam Magnet, Ninette, is asking, what is the worst problem that can be caused by climate change?
Yeah, that's a great question. And the thing about the worst problem is I think that it's certainly relative to where you are and who you are, right? So the crazy thing about climate change is that it affects people differently. And I think that's one of the reasons that we don't see a lot of action on it, is because people that are responsible for making changes for who pass laws and stuff like this, they aren't personally affected, so they don't feel the consequences. However, in LA, for example, if you live in an urban community, you feel climate change, right? Even though, again, we feel it differently, it might not feel as immediate as it might to, again, coastal communities or indigenous people of certain areas. We still feel it in terms of how hot it's getting. So it's the temperature increase in LA proper is bigger because of, we live in the concrete jungle, right? Where heat is just being absorbed. So it really is going to affect all of us differently. I think kind of a high level answer, what's the worst thing that can happen? The worst thing is that it can be too late. That's really the worst thing. We shouldn't compare this consequence versus this consequence. We should just say we're all feeling consequences. And as a result, we need to all come together. We need to be empathetic. We need to care about other people and say, oh, you're suffering from this too. I'm suffering in a different way. We really should come together and make solutions. It might not be easy, but it's important.
And Brandon, as we all feel the consequences, a student from Griffith Steam Magnet, Richard Edgar Pignon, wants to know, how is this also affecting our ecosystems?
Yeah. So that's a great point. I really should highlight that more, and I'll try to talk a little bit about that in the next section. You're absolutely right. We shouldn't just be so focused on us as humans, right? Because we are only one of many species on this planet. So when we look at again, when you look at like melting ice caps, everyone, kind of knows the tales of poor polar bears and stuff like this, who are, seeing their homes destroyed. When we think about one of the things that I learned the most about is that I'll talk a little bit about is called ocean acidification. So as more and more greenhouse gases are in the air, they also get absorbed into the water, right? So our oceans absorb some of that gas. And that means that the concentration of what's inside that water is changing too. So this affects not just people on land, animals on land, but also fish and sea life, because now all of a sudden their water is changing too. If any of you have ever had like fish before, you know that every once in a while you got to clean the tank, or maybe you put some drops of something in there to stabilize the pH, or keep the water clean. Life has a system for taking care of its water, and we're changing that, we're altering that. So that's a real repercussion too.
We do have a very curious question from a student from Walnut Park Middle School, Melvin Garcia. He's saying, so we don't only pollute the ocean, but do we also pollute outer space?
Yeah, so I mean, space is, like I said, is kind of the great beyond, right? And clearly there are issues around taking care of space as well. And we could have, I'd love to come back and tell you guys have another talk with you about space too. But yes, we do pollute in space, or what's called space junk, old satellites, pieces from things that get launched. That's accumulating in space as well. And it's actually a real threat to things like the International Space Station, or existing satellites. You can't have things bonking into each other in space at high speeds. So yeah, I mean, it's pretty wild. One of the things that I know NASA and the international community is doing is to make sure that when we go to other planets like Mars or beyond, that we are very careful about contamination, that we don't bring any dirty stuff with us. We don't bring any germs or garbage, so that we can kind of, make sure that we keep other planets pristine, since they haven't been contaminated yet. So maybe to kind of round out the rest of the talk, I thought I would show you guys just a couple of cool pictures from some of the work I got to do. So last year, I was actually able to explore in the ocean, deep in the Pacific, and I went out with a group that's called the Ocean Exploration Trust. This is Bob Ballard's boat. Bob Ballard is the guy who's very famous for finding the Titanic, and he has a robotic submarine. It's about 7 feet by 6 feet, and as you can see, it's got this cool robotic arm. It's got actually several robotic arms on it, and it goes kilometers. We were 2 kilometers underneath the ocean surface, and I sailed for 28 days, no land. So I flew into American Samoa and sailed all the way to Hawaii. We covered thousands of miles in this boat. I got very, very seasick at the beginning. That was a fun exploration. But this was a team of scientists looking at several things. We were looking at the geology, the rocks underneath the ocean down on the surface, as well as looking for new life, what crazy forms of life exist this deep. But most of all, what I was interested in was, again, looking at the health of the oceans in these deep areas, AKA, have we already seen impact? Has human kind of interference already started to affect some of these oceans in places that are so far away from people? So it was an amazing trip. And, we got to see some really, really cool life down there. This is an eel. The 2 points on the laser are 10 centimeters apart, so about this far apart. To give you a feel for size of some of these things, we saw some amazing jellyfish. And this is one of the ways that we were tracking kind of our human impact. This is one of the robotic arms that has little scissors on it, and we were taking samples from coral, from underwater coral species. And the idea there was, if we could look to see how the coral is doing, is it able to grow? Is it being impaired by ocean acidification, things like that? That'll give us a feel for how healthy the life is, even though this far away from people. So it was really, really amazing research. They do incredible work. I encourage teachers to take a look at their live stream from the dives once the expedition season starts. It was really, really an amazing experience. And really for a couple of reasons, again, beyond the science, is that you get to feel like you're adventuring this wild unknown. We saw these giant octopus and squid, and in fact, saw one of these guys, which looks like Casper the Friendly Ghost here, or maybe like one of the Pac-Man bad guys. So this was a jellyfish, and you can see, kind of its insides. And in fact, even close here, this little orange part is an isopod, a little crustacean that's living inside of it, and it kind of like eats some of the food. I mean, just some crazy things to see this thing like floating around. And it was just an amazing experience. I got to work with the most amazing team of scientists. Here's all of us. This must have been very early on because we all still looked pretty good. 20 days later, you don't look so good at sea. Again, I want to say that there's so many opportunities for us to go out and do incredible research with NASA, with the Ocean Exploration Trust, with NOAA, because we need scientists to go out and really kind of keep track of our planet and keep our planet healthy. And the more science we do, the more we can kind of share it with the community and say, hey, this is a beautiful world, and we need to take care of it. So with that, I'll pause again and just take any last minute questions before we close out.
Sure, we have several questions that have been coming up. So there's a student from Griffith Middle, Aiden Magallon. Will the water be getting hotter as global warming goes on?
Yeah, absolutely. That's a very, very, very smart question. So the answer is yes, right? And the problem with water is that it holds heat so well, right? So think about when you're boiling water for your food, right? I eat mac and cheese like every day. So every day when I make my mac and cheese, because I eat like an 8-year-old boy, I sit there and I watch that water boil, and it takes so long for the water to start boiling, right? So it takes a lot of energy to get it hot, but then once it's hot, it stays hot. And again, if you think about being a fish or a squid or a shark or a whale, if that water stays hot, even if we stopped doing the things that are making the water hot, it's still going to affect you for a long time. So yeah, that's definitely a problem.
And Brandon, going back to the slide of the coral, Moises Enriquez from Griffith's team wants to know, how do you know if the coral is growing or not?
Yeah, that's a great question. And so I'm very fortunate to have been, I'm not a biologist, I'm a chemist by trade. So being with some of these scientists, I learned so much. One of the things that coral do is, they're made out of, well, not all of them, but many coral are made out of like calcium carbonate, which is the same stuff that like seashells are made out of, your fingernails, these kind of things. So when they grow in certain conditions at a certain rate, right? Not all of them the same, but we can kind of keep track. So if you were to try to grow coral in a warm ocean that has a lot of greenhouse gases in it, its growth rate would shrink. So if we can kind of keep track of, first we want like a baseline. So how fast do they grow in the ocean right now? And then we would go back, take another little snip, and how has that growth rate changed? Then we can kind of get a feel for how much the ocean change is affecting the growth rate too. So that's a big question. That's a tough one, and it takes a lot of science, right? So we got to go back. We got to get another piece, and we want to watch how does growth rate go up or go down as the ocean conditions change.
So our final question, I'm gonna have one of our students from Nimitz Middle School, from Brandon to Brandon. Brandon Obi from Nimitz is asking, and I think this will take us to us being global citizens. How can we fix global warming?
Yeah, the amazing thing about what we can do is that there are some things that are big, right? So like the fact that we drive cars or fly planes, those are big contributors to greenhouse gases. They hurt the planet a lot. That's just a fact. I don't expect anytime soon that we're going to get rid of planes. But there are little things that we can do, little things that if we all did every day and just did our part, we could really make a big difference. So one of the things that's an easy thing, I'm not a vegetarian. I'm not advocating that you be a vegetarian. But if you are, you're already doing your part, because the amount of greenhouse gas and water and resources that goes into raised beef, for example, it's a lot, right? So that burger, while delicious, does harm the planet quite a bit. So one thing I try to do, just personally, just in my own kind of way to give to do my part, is I just eat less meat. So I think about my plate and I think about what percent of it is meat. It used to be just a big old steak or something like this. You know, if you cut your meat portions down, you're doing your part. If you ride a bike instead of driving a car, hopefully none of you guys are driving cars right now. You know, tell your parents, hey, let's walk there. It'll take a little bit longer, but why not? So you know, they're just little things that we can do.
Well, great. Thank you, Brandon. Any final thoughts you want to leave with our students?
Yeah, absolutely. I hope you guys see this and take away two really important things. The first is that we need great scientists. So I hope that these pictures inspire you to say like, hey, that's a job. I would love to do that. If you want to travel the ocean with me and you know, race sharks and squid in a submarine, that's climate science. That's research. So you can do good with a good career. And two, even if you don't want to be a scientist, I hope you'll think like a scientist. I hope you'll kind of evaluate some of the stuff that you talk about in your camp from this talk and say to yourself, man, maybe I should do a little something. What can I do? What information is out there? How can I help? Because it is your planet, right? You guys are going to be around for a long time, and I want it to be a good home for you. So, you know, it's never too soon to start. Let's all do our little piece and hopefully make a big change over time.
Great. So Brandon, on behalf of LAUSD and our students from Huntington Park, Vernon Community, Walnut Park, Gage Community, we thank you immensely for educating us and joining you on this exploration of our ocean and the earth and space. And we do hope, students, that you walk away with Brandon's insights, and we do hope that you find it interesting and put this onto your future endeavors to want to explore what is happening. So the earth is waiting for students like you to keep it safe, to keep our ecosystems healthy. So we are excited to see, students, what kind of explorers you're going to be in the future. So again, Brandon, thank you so much for being here with us and providing us with this amazing virtual field trip.
Awesome. Thanks so much for having me.
Thank you.
Take care, everyone.
Take care, everyone.